Hello everyone. In this video we are actually going to discuss how force acts on a charged particle when it is moving inside a magnetic field. We are going to get an expression for the force acting on that particular charged particle. This is also known as magnetic Lorentz force because this formula was explained and expressed by Lorentz. So let us see how it is done. Suppose we have a positive charge Q which is moving with velocity v in a magnetic field B such that v makes, that is the velocity vector, makes an angle theta with the magnetic field B. See this diagram. You can see here the positive charge Q is acted upon by a magnetic field. You can just follow the cursor, I am showing it here. So this is the direction of magnetic field. Then velocity is acting in this direction, as you can see here. So it makes an angle theta with the magnetic field. So there will be some force which acts on the charged particle, which is shown by F. In the z direction, the velocity vector and the magnetic field, they are in the xy plane. So the resultant force on the charged particle is along the z direction. So we are going to discuss this force only, and we are going to see on which factors this force depends. So let us see on which factors the force depends. The force which you can see is acting on the charge Q is proportional to the magnitude of the magnetic field. That is, if you increase the magnetic field, the value of force on the charge will also increase. Suppose two different magnetic fields are there in the same direction. The first one 2 Tesla and the second one is 10 Tesla. So when it is 10 Tesla, when the magnetic field is more, then the force will also be more. They are directly proportional here, as shown here. Now the next factor is the charge, the value of the charge itself. More is the value of the charge, more will be the force acting on it. So force is also directly proportional to the charge. The next is the very important thing. This force F will be directly proportional to the component of velocity in a direction perpendicular to the magnetic field. You can see magnetic field is along y-axis. So along x-axis, the component of velocity is v sine theta. So the force acting on the charge Q is directly proportional to the component of velocity perpendicular to the applied magnetic field, which is v sine theta. All these values, that is the force which is directly proportional to the magnetic field B, it is directly proportional to the charge, and it is directly proportional to the component of velocity perpendicular to the magnetic field v sine theta. All these are calculated experimentally by Lorentz. So that's why the force which we are considering here, it is also known as magnetic Lorentz force. Now, when we will combine all this dependence of many factors, the force can therefore be written as to be proportional to, directly proportional to B Q V sine theta. Or if we remove the proportionality sign, then an equal sign will come and we will write a proportionality constant K. So force becomes K Q V V sine theta. Now the value of K comes out to be 1, that is unity, when we consider appropriate units of all the quantities. You can see here the unit of magnetic field is so defined that the proportionality constant K becomes unity in the above equation. That is 1, K is 1 according to the units which are chosen for the other quantities, that is magnetic field, charge, as well as velocity also. So the value of force now will be given by q v b sine theta. So this is the magnitude of force acting on a charged particle q moving with velocity v in a magnetic field B. Now this is the force which is responsible for deflecting a charged particle moving in a magnetic field, and this force is known as magnetic Lorentz force. Now you can see here the force, the direction of force is perpendicular to the plane of V and B. Like the two vectors, velocity vector and the magnetic field, they are in the xy plane, but the magnetic field is along the z-axis. That is perpendicular to the plane which contains V and B. Actually, what we can write here in vector form is q v cross v. Vb sine theta, it is written as v cross v. And we know that cross product of two vectors, the direction can be calculated by right hand thumb rule or right hand screw rule. So you can see here, if we take a right-handed screw and if we rotate it from V to B, it will move in the upward direction. Or if we take our right hand and we take the curved fingers from V to B, then the thumb will be along the direction of force. So the direction of force is given by the direction of V cross V. So we can use the cross product rule to find the direction of force. And as we can see, the value of force is perpendicular to the plane which contains the velocity and the magnetic field B. Now, some of the spatial cases we will be considering here. Just now we have discussed that the value of the magnitude of force acting on a charged particle q moving with velocity v in a magnetic field B such that there is angle of theta between V and B is given by q v b sine theta. This is the magnitude of force, and in vector notation it is written as F is equal to q v cross B. Now some of the cases we are going to discuss. The first case is if the velocity is 0, naturally the force will be 0. You can put V is equal to 0, the force is 0. That is, if the charged particle is not moving, if it is kept in a magnetic field also, but if it is not moving, then there is no force acting on it. A stationary charged particle does not experience any force in a magnetic field. Clear? Now next case, if the theta is 0 or 180 degree, that means if the charge q is moving in the direction of magnetic field or opposite to that of the magnetic field. That is, suppose we consider here that the charged particle is moving in the direction of magnetic field, then the angle between V and B will be 0 degree, and if it is 0, sine 0 is 0, that means force will be 0. If the charged particle is moving in a direction opposite to that of the applied magnetic field, then the angle theta becomes 180 degree, then also the force is 0. So in the two cases where if the charged particle is moving parallel to the magnetic field or anti-parallel to the magnetic field, the force on the charged particle will be 0. I hope this is clear to you. Now next is, if the angle is 90 degree, that is, if the magnetic field and the velocity vector makes an angle of 90 degree with each other, that is, if theta is 90, then sine 90 is 1, which is the maximum value. So the force will be given by qvb, which is the maximum value of force. That is, a charged particle experiences the maximum force when it moves perpendicular to the magnetic field. So I hope this is very clear to you. This was all about the force acting on a charged particle when it moves in a magnetic field. The magnitude of force is given by q v b sine theta, and in vector notation it is written as Q V cross B. The direction of V cross B, that is the direction of force, is given by right-handed thumb rule or right-hand screw rule. So I hope this is very clear to you. Any doubt if you face, you must post me the doubts. Thank you.